day 3, and this is the first time we're going to start talking about grade 9 stuff. Day 1 and day 2 is basically a review of grade 8, maybe a little more trickier graphing than you would have done in grade 8, but you've done most of those concepts before. So, at the beginning of this chapter, I mentioned that there's 3 main ideas: graphing, data tables, and equations. So we've done everything in black here. We used equation to make a table, and we graphed it, and we've taken stuff off the table, we graphed to make a table. Today we're doing this red arrow. If you have a table, how do you come up with the equation? Okay? So now, sometimes you have to create your own table. A table is just a picture of a pattern in the table format. So when we create this equation, all equations of the line, they're all going to look like this. Okay? Y equals a number times x. So a number in front of an x is called a coefficient. Then you're going to be adding or maybe subtracting another number. Then a number by itself is called a constant. Okay? So in order to create an equation, you need to figure out 2 numbers. You need to figure out what the coefficient is and what the constant is. So some of the questions are going to be, here is a pattern. Figure out what this pattern is doing. So this question down here is we have a bunch of hexagons being added along, right? And most students are pretty good at this stuff. They figure out the steps, and where they make the mistake is they count the wrong thing. So you have to make sure you read the little sentence that goes with each question. Because sometimes the question will ask you to come up with a pattern of, hey, how many shapes are there? Or it may ask you a pattern of how many sides there are. Or it may ask you for perimeter. It depends on what they're asking you to count. So just don't assume. So in this question, it asks us to find a relationship between the figure number, so which diagram it is, figure 1, figure 2, figure 3, figure 4, and how many sides are in the perimeter. Okay? So we're going to make a table, and that's going to help us create the equation. So we have our first figure on the far left here. Okay? How many sides are in the perimeter of this one?
6.
6. We count them up. 1, 2, 3, 4, 5, 6. Then we look at the second figure and go, okay, how many sides are in the perimeter here?
10.
Thank you, Max. There's 10 in this one, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Keyword perimeter, meaning outside sides only. Inside ones don't count, right? So you got to make sure you're counting the right ones. So now it goes figure 3. So each time, so we have to draw it out. Okay, what's happening each time is we're adding a hexagon on. So maybe it's on the top, maybe it's on the bottom. It really doesn't matter. For simplicity's sake, I'm just put it on the bottom. So when you're drawing a new figure, I suggest you start with the old one, draw that one out, then add on the new part. So figure 2 is a hexagon like this. In science class, you'll learn that this is a benzene molecule. Benzene molecules are aromatic. You'll start learning about this in chemistry when you get to high school. And those are the ones that have a lot of scents and smells to it. Right? So that's figure 2. So I'm going to add on an extra hexagon here, like so. And we're going to count up how many sides are in the perimeter. How many are there?
14.
14, thank you, because you add up all the sides, there are 14. So we have 3 here and 14 here. Now, I really don't want to draw off the 4th diagram. You can if you want. But this whole class is about learning patterns. Right? So, look at this table. Without drawing the next one, can you tell me how big or how many sides the 4th figure will have?
Yes.
Ryan, how many sides will the fourth one have?
18.
18. How do you know that?
Because the pattern. Because the pattern.
What's the pattern, Ruben?
6, 10, 14, 18.
Yeah.
Goes up by 4.
Goes up by 4. Plus 4, plus 4, plus 4. Okay. So we started off with this lesson saying, hey, when we create the equation, Julian, we need to come up with two numbers. A coefficient and a constant. Ruben and Ryan just looked at the table and saw the pattern. That pattern that you noticed is one of the numbers. That's your coefficient. Alright? So we figured out what this m value is. So I'm going to just put on our side notes here is we figured out step 1. That's going to be 4. Okay? And now what we're going to do is create our equation for this. And typically we say it's y equals, but y and x are general. Alright, sometimes we use y's and x's, but sometimes we don't. Depends on what we're talking about. When we have our table, our first column here is always x. Our second column is always y. So instead of saying y equals, we're going to say s equals. Actually, I'm not going to say s equals either. I'm going to say sides. These my s's looks like 5s. I don't want that confused. So here, I'm going to start creating my equation. And I'm going to say it's sides equals, and the pattern that Ruben and Ryan figured out was, hey, it's going by 4, so I'm going to put a 4 here, and then instead of x, I'm going to put down the letter n. N for figure number, right? That's what they use right there. Okay? So, we've done creating a partially or equation. We just need to figure out what the constant is. To do that, we test out how well our equation is working. So we go, okay, we've created this, 4n. So you pick a spot on the table. Doesn't matter what spot. I like the top spot because the numbers are usually smaller and easier to work with. This is the equation we created so far, right? If our equation works, when we stick in the number 1, we should get 6 out. So it doesn't work this time. So we go 4, we stick in the number 1, and we get 4.
You should add the plus 2.
So to make it work, we need to add plus 2. So over here, we can go plus 2. And that's our equation. And sometimes when we do this, when we come up with your equation, we make a mistake at looking at the pattern. So once you created your equation, you go to a different spot on the table and test if it works. Right? Because this should work anywhere. So we look at here, you pick a spot, any spot, right? Lucas, you want to pick spot 2, 3, or 4? 4. So you Lucas picks spot 4. So next to spot 4, I'm going to write out the equation, 4n plus 2, right? If we stick 4 into this equation, we should get 18 out if we did it right. So you go 4, and you stick the number 4 in. Plus 2. So 4 times 4 is 16. 16 plus 2 is 18. And it worked. Done. You created an equation for this pattern. So with these questions, there's probably only 3 questions I can ask. One is, can you create an equation for this pattern? Which you just did. The other 2 questions are going to be, hey, can you predict what a future pattern looks like? For example, right here. Here it's asking you, what does figure 13 look like? How many sides are there? Now, if you went further down, now you could draw the 13th figure and count the sides. You could take this table and make it super long and just keep the pattern going, right? And those are the strategies that if you're in my grade 7 class or grade 8 class, I say, hey, let's do this. And in grade 9, we want to use equations. And if you forget how to do the equations, you're stuck on the test, you can go back to just drawing and counting or making a table, right? But now, we want to do things hopefully a little more efficiently. So we have this equation here that connects sides and figures together. We have sides equals 4n plus 2. right? And we want to figure out how many sides the 13th figure has. We need to plug 13 into this equation. We've only got two spots where we can go. Does the 13 go in for the sides, or does it go in for n?
N.
N stands for figure, right? So where we see n, we're going to replace it with the number 13. And remember, when we substitute, we do it with brackets. So
4 times
13 plus 2. So you go 4 times 13, right? So that's like a 52 plus 2, so it's 54, right? So we can say the 13th figure has 54 sides. Okay. Question 1, what's the equation for this pattern? Question 2, how does a pattern further down the line look like? Question 3. Somewhere down the line is a figure that has 82 sides. Where is it?
Yeah. We should reverse the.
Yeah. So you could do like other things. You could draw it out and kind of figure it out, or do the table, right? But let's use the equation again. We have sides equals 4n plus 2. This time, we want to stick the number 82 in. Ruben.
Can't you just divide 80, well, like minus 2 from 80, and then divide 80 by 4?
Yeah, that's what we're going to do.
Yeah.
Good logic. I think he did it without even using the equation, right?
Yeah.
All right, but we're going to set it up with the equation, right? So 82 goes in for sides, because that's what this separate represents. And Ruben is seeing the math in his head. That's great. So now this is a question from last chapter, and a question from grade 8, right? This is an equation we have to solve for. We need to figure out the value of n, right? We go like this. We cover up the side that doesn't have the letter. We have a 4 and a 2. Which number do we get rid of first?
2.
2. And Ruben said we subtract 2. So we go subtract 2. Minus 2, minus 2. 82 minus 2 is 80. And we have a 4n left over. And Ruben said we're going to divide by 4 next, right? Get rid of the 4. So you divide by 4. Divide by 4. And 20. Right? So we can say the 20th figure has 82 sides. Right? And for this chapter, in terms of solving equations, that's as difficult as it gets. We're not going to get into the brackets and the fractions like we did last chapter. Right? That's the difficulty that we get. We carve up the side, we do the adding, subtracting first, then we do the multiplying, dividing side. Right? So that's the difficulty level of that. So,
Should we write the formula at the question?
yeah, write the formula. Okay, let's do another one. Okay, here. So reading the question carefully on the back side of this page. Right? What is it asking you to count this time? Is it asking you to count sides?
No.
No, what is it asking you to count?
Triangle.
Triangles. Right? So, our first diagram. Right here. How many triangles are there?
1.
Just one. Then we have our second diagram. How many triangles in that one? 3. Third one. How many triangles are there? 5. 1, 2, 3, 4, 5. All right. 3 and 5. Okay. Without drawing the fourth one, what's the pattern? How many triangles would the fourth one have? Ruben?
7.
7. Because it's going up by how much? 2. Up by 2. Up by 2. So it's going to be 2 more. 7. And this is going to be 4. And the fifth one's going to have how many? 9. Okay, so now this diagram with the triangles, it's a very common pattern question that shows up in grade 10 and in grade 11. They can ask you different kinds of questions about it. Sometimes students have trouble drawing it. So my tip to draw these is, hey, notice that figure 1 has 1 triangle on the bottom, figure 2 has 2 triangles on the bottom, figure 3 has 3 on the bottom. So when you're asked to draw a feature 1, just draw like mountains. So figure 4, I can draw 4 mountains, then I can draw a line through the top. Right? So if you had to draw it, you go 1, 2, 3, 4, and just connect up the tops. Right? This is a very common one. It's going to show up a lot. So sometimes people make mistakes just drawing it out. And obviously you can get the wrong answer if you didn't draw it correctly. Right? Right? So the fifth one's going to have 5 mountains. So we look to create our equation. Right? We go y equals, or that's our second column. So we're going to go t equals here. T equals, you guys notice that the pattern was going up by 2. So t equals 2n. That's our equation. And we're going to check how well it works. So take any spot on the table. I always like working with the first one because the numbers are always just usually 0 or 1. So I stick it right there, 2n. I stick the value of n in. There you go. So 2 times 1 equals 2, but it should have been 1. What adjustment do we need to make?
Minus 1.
Minus 1. So this time our constant is minus 1. We go minus 1 equals 1. Minus 1. Then we go, okay, let's make sure we didn't make a mistake with determining any of those things. We test it out with any other spot on the table. Doesn't matter which one you pick. Julian, which one? 1, 2, 3, 4, 5. Where do you want to test it out? 2. 2. All right, so we're going to test it right here. 2n minus 1. So 2 times 2 this time minus 1. So we get, 4 minus 1 equals 3. It works. Right? So you came up with a relationship. Next step is just using it to figure out other patterns in the list here. So next one. Somewhere down the line, figure 71 is there. How many triangles are in there? So we start off with our triangle. T equals 2n minus 1. Where does the 71 go? T or n? Sorry? N, yeah. N stands for figure, right? So we go 2, we replace it with 71 in brackets, minus 1. T equals, do the calculation. 142 minus 1, 141. Right? So we can say or maybe not the, let's say figure 71 has 141 triangles. Okay. And the only third other question I can come up with is, hey, there are 63 triangles. Which figure does it belong to? Right? So we're going to do one more question after this one. We have triangle, not triangles. T equals 2n minus 1. Where does the 63 go? T or n?
T.
T. So 63 here. And now you solve it. What's the value of n? Remember, add and subtract first, then multiply and divide. Get rid of the 1, then get rid of the 2. Right? Can you do it in your head? I'm hoping you can do this in your head.
Yeah.
Right?
Yeah. 32.
32. Add 1 to both sides, gives 64. Divide by 2, half of 64, 32. Right? Add 1, 64 equals 2n. Divide by 2, n equals 32. Right? Figure 32 will have 63 triangles. And we're done. Okay? Just one more question, and you guys can take a break. Alright? We're going to do, it's a long lesson, as in lots of spaces, but not that many questions. Just all these questions take up space. So, we're going to do the top right-hand corner. This time, we are not counting anything. You're just given a table with the pattern in it. You're not even told what you're counting. All you're told is a D and it's T, and come up with the equation between D and T. When you're coming up with the equation of the D and T, you need to know how to start it off. Is the equation going to be D equals, or is it going to be T equals? That's the first thing you got to guess.
D equals.
It is not D equals.
Oh yes, T equals.
So remember, we have an X column and we have a Y column. Our equation is always Y equals. So it's whatever is in the second column. So it's going to be T equals. All right. T equals. Okay. Then you look at the pattern. What's the pattern here? Plus 5. Good. Each time. So 5, not N, but D this time.
Oh, 5D.
Because the other side's called a D. Because this side's called a D this time. Last time it's called an N. Right? So, we tested it out. We have 5D here. We stick in the number 0. We do our calculation and see how we need to adjust it. 5 times 0 equals 0, but it should have been 11. So what do we need to do?
Plus 11.
Plus 11. Plus 11. Okay. And then we just try it out with another spot. Doesn't matter. Lincoln, where do you want to try it? 1, 2, or 3? 2. So we said our final equation is this. 5D plus 11. So where we see D, we're going to stick in the number 2 this time. So you have 5 times 2 is 10 plus 11 equals 21, and it works. Okay. That's it. Right? There is a little bit of trickiness in some situations, which we'll talk about next day. But this is the general idea behind it all. And I'll just talk about the tricky situations next day. And so we'll do a last couple of questions next day, and we'll do the assignment. So that'll be on Monday when I see you.